you are seeing the collab notebook. The first thing we are saying is import NumPy. We will keep going through that again and again so that some of these commands become easily understandable to you. As we said, that NumPy is one of the set of libraries which we'll use for different types of computation. Similarly, and so before we start using those libraries, we need to import that into our Colab notebook. And as we import it, we give them as an alias or as a name. So we are importing NumPy and we are giving that a name as NP. We are also importing pandas. Pandas is this set of libraries for data manipulation, and that we are naming as PD. Then the numbers that we had got, that probability of the disease or probability of that cause, and when we say disease or cause, it is, we are saying that what is the probability of smallpox, chickenpox, acne, and so on. Those are the numbers that we are defining here as an vector. Okay, so he has defined one vector and named as probability of the cause in the general population. And if you see, we have given the same numbers as it was there in the Excel. And these numbers represent that what is the probability of that particular cause or that particular disease in the general population. As we type this variable, then it shows us the result. So we just confirm that yes, the variable that I have defined, and that variable represents a vector, and the elements in the vector are shown here. And then we just confirm to ourselves that yes, the variable has been defined properly. In pandas, you will see that when we define the variable, we don't have to define that what is the type of the variable. By seeing the notation of that variable, it automatically understands that whether it is a scalar or a vector or a matrix. And that makes all the future operations so much simpler. So unlike some of the languages like Java, where we have to very strongly typecast the variable, where we need to define what is the type of the variable, whether this is an integer or a double or a vector or an array. That definition in Java we do upfront, but Python is much simpler. We don't have to do that thing. The system itself is intelligent enough to understand that what is the type of the variable. So we have defined an array which is having the probability of that particular thing happening in the population. How do I erase this one? Okay. Similarly, the next question that we had to ask is that what is the probability of appearance of the spots given that we know the cause or given that we know what the disease is. So these were the numbers which we had used even in the previous, these were the numbers we had used even when we are using or when we are computing it in Excel. And these are the numbers which represent that what is the probability of a spot appearing given that a person has smallpox or a chickenpox or an acne and so on and so forth. And then again, we just type out the name of the variable, and that gives us the content of the variable is printed out. So we confirm that the variable has been defined properly. Then the third element that we needed to have was the probability of the spots in the general population, and that was 30%, which we had also used in the Excel. Now you see that to get the result of how many now I have all the three ingredients which we can put into the Bayes theorem. What we are trying to find out is that having known that we have having known that a person is having a spot, what is the probability of he suffering from chicken pox, smallpox, and so on and so forth, all the diseases about which we have data. What we are doing is that we are invoking one of the methods from our NumPy library, which is multiply. So we say np.multiply, which reads like invoke the multiply function from my NumPy library. Okay, so I have invoked the multiply function from my NumPy library. Then within the brackets, it's the different elements which go into computing that or required by that method. Is that the arrays? So first we are wanting to multiply the elements of array 1 with elements of array 2, or elements of vector 1 with elements of corresponding elements of vector 2. So I have defined the vector 1, I have defined the vector 2, and then the system would multiply element by element. Now, if you recall our previous discussion as to vector multiplication, we had used np dot, and here we are talking about np multiply. So np dot was for multiplication of one vector with another vector, and that was a cross product. That is the way that we learned how to multiply a vector with another vector, and there the dimensions were important. So 1 into 3 could be multiplied only by 3 into 1. That those principles would apply. However, in the NumPy library, we also have another command or another method which does the multiplication of one vector with another element by element. It means that the first element will be multiplied by the second element would be multiplied with the the first element would be multiplied with the first element of the second vector. Second element of first vector would be multiplied by the second element of the second vector, and so on. So corresponding elements would be multiplied. For that, we have a separate command called multiply. So we will invoke that function and then provide the names of the two vectors which I want to multiply, and that gives me the result. So this part is giving me the result of multiplication of the two vectors, and then we divide that by the probability of the spots in the population in general, and then we get the data for each of these diseases. So these numbers are the same. As you can see that this is the probability that he is suffering from the smallpox. This is for the chicken pox. This is acne. This is skin cancer, and so on and so forth. So the multiplication, or the way that we arrived at these things using the Bayes theorem in Excel sheet. Now the same thing can be done in a much more simple way in Python. Now the beauty of Python is that you don't really have to write the commands every time. Once you use it, you can run that. You can go on changing the input variables, and the output variables will go on changing. Now, having got this answer here, now if I have to really deploy that in the real life situation, I will use this output, and then I can use this output to our decision matrix as to if the confidence level is 80% or more, then we could say that start the treatment of acne right away, or whatever decision matrix that we decide. This result could be fed into that decision matrix, and then a proper decision could be taken by the clinic or the hospital. Okay, so this was with this we have a fair understanding of how probability can be used, or probability can be combined with the concepts of machine learning, and it can be used in the real life situations. We also briefly talked about, and about which we will talk about in much more detail later on, as to when we go into the real life situation, then how some of these output of the machine learning algorithms can be used. Let's not be under the illusion that just because we are learning artificial intelligence and machine learning, whatever is the output that we get, even though the confidence level is very high, it can be used as is in real life. That's not going to happen.